Okay guys, so what we're going to do is we're going to discuss the actual exercises we would have done for the reflex lab. The idea is that we would have started with a somatic reflex. A somatic reflex implies that the effector is skeletal muscle. Specifically what we've done is we would have demonstrated a stretch reflex. To demonstrate a stretch reflex, we would have picked on the patellar reflex. You can elicit this if you can pop up on a countertop and using a device like this is a reflex hammer. If you strike just below the knee, you should be able to get a response. This is something that you may have encountered if you've gone to your doctor and they've had a check of your reflexes. Alright, the idea is that out of the group that was at your table, we would have picked one person to pick on who had a very good sort of reflex. The idea is we would have then run them through this first set of protocols. The first part would have been addition. The idea we would give them a math problem to do. The second protocol would basically have them grab onto the edge of the desk as they are sitting there. Okay, not pushing down, but grabbing and pulling themselves into the desk. And the last one, and why you may be thankful you didn't actually come to lab, is that you would have had the test subject going up and down the stairs for 5 minutes. Okay, now, the idea with all of this is that the first two cases should not affect the amount of response you get at all. Okay? The idea is that a math problem and that the muscular exertion of your arms are not going to involve the spinal cord segment that is associated with your patellar reflex. The idea is basically just that they're nowhere near where the reflex comes into and out of the spinal cord, so in no way could interfere. We would potentially expect a response in 3, dependent very much on the condition of the test subject. The idea is that if the test subject actually fatigues, gets tired, then when they come back you would expect that the response would be very much limited. In other words, reflex would be less. If the person's in fairly good shape and they're not fatigued at all and could go another 20 minutes, then truth is their reflex may be the same. Alright, the idea and the reason we do this is basically to show that you can't actually affect the function of this reflex arc, okay, but we can influence the effector portion. Okay, so we can't mess with the receptors, we can't mess with the sensory and motor neurons of the processing, but what we can do is we can affect the ability of the effector to respond to the message. So even if I had everybody go up and down the stairs for 3 hours and they were completely and totally exhausted, dragging themselves in, they would have gotten a much less visible reflex. But it's not because of the receptor, it's not because the sensor and motor neuron. All of those guys would have functioned as if they had not done any of that stuff. The only thing that would be different would just be the muscle. Alright, we then transition into the autonomic or visceral reflexes. The idea is that these are going to involve effectors that are going to be not skeletal muscle, but rather visceral effectors, smooth muscle, cardiac muscle, glandular. The idea is we would have started off with a pupillary reflex. We would basically be looking at the eye and specifically examining the size of the pupil. It's important to point out that the pupil itself is a whole. The muscle that controls the pupil and its size is the iris. That's what's actually colored and pigmented in people. The idea is that the iris is a bit of smooth muscle. That's why it falls as a visceral reflex. Alright, the idea with this one is that when you take a flashlight like this and you shine it in someone's eye, the idea is that you are putting extra light in their eye. That's the stimulus. Okay, and we should see a response that negates that. Okay, that's typically what reflexes do. They negate that sort of thing. Okay, and so the idea is that when you shine the light in the eye, more light hits the retina. You are then going to use your cranial nerves to get the information to the brain and back from the brain so that you can then constrict the pupil so that less light is actually getting into the eye and through the retina, so that we return it back to a normal level. All right, now what's important here is to note that this is a consensual reflex. All right, the idea with consensual is that it involves both a contralateral and ipsilateral response. Okay, so the idea is that if you have the test subject with the flashlight in their right eye, and their right eye constricts, gets smaller, then the idea is that part of the consensual response is the ipsilateral part. If you're looking at that person and you observe, which you should, that at the very same time that the eye that does not have the light, in this case, if the light's in the right eye, it's the left eye, also constricts, then you're seeing a contralateral response. It's important to note that that automatically means that there are two effectors. Because there are two effectors, then this has to be a polysynaptic response. The ciliospinal reflex, okay, which is here, is just to show you that one effector may in fact be used by multiple reflexes. The idea with a ciliospinal reflex is that you still look at the pupil. However, what you do to elicit this reflex is you take this portion of the reflex hammer, this pointy end, and you stroke it up the back of the neck. So we are using a tactile stimulus in a completely different location to try to get a response. Okay, now typically this one's tough to get, but if you can see something, what you typically see is pupillary dilation. That is to say, the pupils get bigger in size. Okay, that's a different response, even though it's the same effector, because it's a different reflex. You are responding to a different stimuli. Okay, now in this case, what causes the pupils to get bigger is that when you stroke the hammer up the back of the neck, you are actually getting the sympathetic system kicked on, as is noted here. And the idea is that doing so is going to elicit a response in the sympathetic system. Now, if you think about sympathetic system, fight or flight, you kind of want to be able to see something you have to run away from, or what you have to run around to get away from somebody. You kind of want to see what you might have to fight, so it makes sense that your eyes would open up. All right, the last reflex, the salivary reflex, this is simply to show that it doesn't have to be a muscle involved with a reflex. In this case, we take the visceral effectors, which are glands, the salivary glands, and we are going to elicit a response from them through the use of a stimulus of lemon juice. Okay, so specifically what we're going to do is using these two things, graduated cylinder, a beaker, and in addition to the pH strips, you have a test subject. Hold, or refrain from, I should say, any talking, laughing, or swallowing for 2 whole minutes to get what amounts to a baseline amount of salivary gland activity and the amount of saliva they make. Okay, so typically speaking, you get, for most people, it comes out anywhere from half a mil to maybe a couple mils worth of volume. cc is just milliliter, and the pH should be around neutral. Okay, the idea is that you then take some lemon juice, and typically I do 10 instead of 2 to 3, and then you put it on the tongue, and then you take a pH measurement of it. Because it's lemon juice, which has all of that acidness to it, you should expect that the pH will drop all the way down to perhaps 2 or 3. Okay. Again, the idea is that the person refrains from swallowing. Okay, and then after that additional 2 minutes, they then again spit into this to get a volume, and use these two to get a pH. And what we should see is a huge increase in volume. Usually it's at least a doubling, sometimes tripling. I've seen as much as like a 10-20 fold amount. Okay, I've seen people fill that up and then some. But the point is that the volume goes up greatly, and just as importantly, the pH comes back toward normal. I don't typically see people get a complete return to neutral, but it does get more toward neutral. Okay, so it becomes less acidic than it was once we put in the lemon juice. Okay, so to think about this in terms of the reflex arc, the lemon juice, it's not just any old part of the lemon juice that's important here, it's actually the acidicness of it. In other words, its effect on the pH. Okay, and the fact that it contributes all of those acids which drop the pH. That's what actually triggers the pH receptors that are associated with the tongue, which then by a set of cranial nerves goes to the brain, and then by a separate set of cranial nerves brings back the command to the glands to produce copious amounts of saliva, that's to say lots and lots. And the idea is that all of that extra saliva is actually going to dilute the pH. Okay, so the idea here is that it's not about buffering. Okay, we don't have a lot of buffers here. Instead, what we do is we change the concentration of H+, not by altering the amount of H+, but simply by altering the volume that the H+ is found in. Okay, basically imagine some Kool-Aid where you don't change the actual amount of powder that's in it, you simply double the amount of water you put. Okay, you've definitely changed the concentration. So in this case, adding the extra saliva effectively lowers the concentration of H+, and if you lower H+, then pH goes up. Okay, so it's dilution. It is worth noting that people typically don't refrain from swallowing for 2 minutes at a time, and so it is worth noting that a lot of this is also going to be that we wash those excess H+ ions off to the stomach as well. Okay, so get them out that way.